Alright, so we're going to start the chapter on moles, and what we're going to do is we're going to use math, and we're going to use chemical formulas to find some stuff out about atoms and molecules and that kind of stuff. So this is something you've never done before, so you want to keep that in mind that you're going to have to practice and you're going to have to look stuff up. And if you're looking in your book, which would be a great place to start, this is where you're looking. We're on pages 286 to 319. So there's a specific chapter in your book on this, and that's where you want to be looking for it. Alright, so the first thing we're going to look at up here is the atomic mass, and atomic mass is just the mass of one single atom. And if you think about that, that means it's going to be very small, and that makes sense because atoms are really small. And when they did this, they had to come up with an idea of like what was it based off of. So what they did is they decided they were going to base it off of carbon-12 because we are carbon-based life forms. So they figured carbon had to be important because since we are based on it. They came up with its own units, which is the atomic mass units, or for the shortcut, it's just called AMUs. And all you have to do for an atomic mass is just look it up in the periodic table. So it's very simple. There's not really math or anything involved with it. Now you want to keep in mind that this is a relative mass, so this is a comparison. So what they did is they figured out the mass of a carbon atom, and then they are comparing the two. And atomic mass units is kind of like vague. We don't really know what that means. So what they are saying is this is the conversion factor. So if you wanted to, you could convert AMUs to grams. And obviously that's really, really small. And again, because atoms are really, really small. So what we're going to do is just do two quick, let you try to. But what you want to keep in mind is that to be all on the same page, because periodic tables can vary, you need to make sure you round to the tens place. So if we're looking at this first one down here, calcium. When you look up calcium on the periodic table, his thing is 40.08, which is great. But again, say you had a different periodic table than someone else, it could be slightly different. So what we're going to do is just make sure that for that one, then you round it to the tens place. So your answer for atomic mass would be 40.1 AMU. And it's that simple. Look on the periodic table, find the element, find the given average mass that they give you, and then round it. If we look at sodium, sodium is 22.99. So again, we want to round it so that we're all on the same page. So when we round this guy, we're going to be at 23.0 AMU. You want to remember to round to the tenths, and you want to make sure that you have the AMUs there. So I'm going to give you like 20-30 seconds. Just try and find out chlorine and scandium just so that, make sure you have it. All you need is a periodic table, and you just want to make sure that you're rounding to the right place. Alright, so your answer for chlorine should be 35.5 AMUs. And for scandium, that's 21. You should have 45.0 AMUs. So the biggest thing, find it on the periodic table, round it to the tens, don't forget your units. And then also make sure that you understand what it's based on. Formula mass is very, very similar. The only thing that's different with formula mass is that now you're not dealing with a single element. It's a little bit bigger. So you're still going to find your atomic masses, but what you're going to do is sum them all up. And again, you're going to round to the tenths and everything. So if we're over here and we're looking at our iron sulfate, what we're going to do is do each individual element. So like if we're doing iron, we have 2 irons, and each iron is 55.8. Then we go down to sulfur, and you have to make sure you distribute. So when you distribute through in the parentheses, we should have that there's 3 sulfurs. Again, look it up on the periodic table, and each sulfur is 32.1. And then last but not least, oxygen, multiply through. So we have oxygen here, we have 12, and each oxygen from the periodic table is 16.0. So if you multiply these out, the iron you get 111.6, sulfur you get 96.3, and oxygen you get 192.0. So you add them all up, that's going to be your answer, and you're going to get that your answer for this guy is 399.9 AMUs. And that would be your answer. Sorry, I'm not very good at circling with this one. All right, we'll try letter B together. So for nitrogen, again, distribute through, we have 2 nitrogens. If you look him up on the periodic table, he's 14.0, which is, when we multiply, 28. And it seems silly, but very soon you're going to know randomly what elements weigh, because it's just going to help you. So you'll know how nitrogen's 14, you'll know carbon's 12, you'll know hydrogen's 1, oxygen 16, that kind of stuff. We have 8 hydrogens. Each hydrogen's 1. Grand total of 8. Carbon, we have 1 carbon. Carbon's 12. And last but not least, we have oxygen. There's 3 of them. Each oxygen 16. 48. And then we just add that all up. So you just take your calculator out, type it in. So we get 28 plus 8 plus 12 plus 48. And we get that our grand total is 96.0 AMU. Last one, formula mass, I want you to see is one where you have a hydrate. So there's a couple of different ways you can do this. You can either do the copper and the copper sulfate by itself and then do the water, or you can put it all together. I'm going to do it where I do the copper and sulfate by itself and then add it. So if I look at just copper sulfate and I kind of ignore the water for right now, I'm looking at copper. I have 1 copper, it's 63.5. I have 1 sulfur, it's 32.1. Sorry about that. Hold on, let me make sure I'm actually on this. Here we go. This should say 32.1. That's my own fault. Oh, it's not letting me write. Hold on. It should be a 1. 32.1. And if we're looking down here. Oh, it doesn't like me all of a sudden. We have 4 oxygens, and each of those is 16. And then the last thing you do is you look at the waters. Now, what you have to be careful of is that you're going to have to distribute up here. Hold on, let me just fix something on my computer. It's being funky. There we go. All right, now let's see if it likes me anymore. Hold on, let me... It doesn't like me. There we go. Let's see if it likes me now. For the waters, this 5 has to go through. So instead of just having 2 hydrogens, I now have 5 times 2. So for the water part, I have 10 hydrogens, and each hydrogen is 1. And then I have to distribute through for the 5 for the oxygen as well, because it goes through the whole thing. And that means I have 5 oxygens, and each oxygen is 16.0. So we multiply that through, and that's 80. So all you do then is you add all of these up, and you'll get your answer, which should be 249.6 AMUs. Now, it's great talking about atoms, but that's not something we can see. So the whole idea between this mole chapter and everything with the moles is very abstract, and it's hard for high school students to get it. But what the whole idea is basically is that we can't see atoms, and we don't really want to deal with atoms. So what we're talking about is going from this very microscopic AMUs, and we're trying to get up here to grams because we can measure grams. We have balances and stuff that can do grams, so that's what we're looking for. And what it said when you have a mole is mole is an amount of a substance. And what they did is they took exactly 12 grams of carbon 12. They divided it and they figured out how many particles are in there. And what they figured out is there is 6.02 times 10 to the 23rd particles in there. So that is called the mole, which is a huge, huge number. But that's where it comes from. So, really to help you, it's abbreviated MOL. That's not what I wanted. Sorry. So it's MOL, takes off the E, and then if you're trying to write as short as possible, the symbol for it is N. So basically, anytime I say a mole, we're talking about 6.02 times 10 to the 23rd. That's called Avogadro's number, this guy right here. And we're going to use it for problems, which we'll do in a little bit. So again, it says if I say I want a mole of apples, you're getting me 6.02 times 10 to the 23rd. If I say I want a mole of paper, you're getting me 6.02 times 10 to the 23rd. That would go to the sun and back a couple times. So it's a large number. And then every year there is International Mole Day. It's always October 23rd. But this is one of their themes. So this was, remember the Alamo. I don't know if I have any more. Oh, no, I don't. So we'll come back. We'll look at Avogadro a little bit, and then we'll do some problems, and we'll be done for the day. But you have to know this Avogadro's number.